So, should you use your data or the data that I'm giving to you right now?
I'm going to say the data you give it to us.
Okay, why would you use the data that I'm giving to you?
Yours is more accurate and precise.
More accurate, more precise. It's a crucial difference.
If anything, probably more accurate.
Like,
Did you get these, Olivia, or you knew? It's a new one. I gave you a new one too. Alright, in this. So a couple things to go over with what you're looking at. First of all, what I've given you. I've given you a new data table. First, because I want you to get this data down that I've given you. Alright, then I'm going to explain to you and show to you is how we're going to make some calculations to figure some things out. But also within that, we're going to have the pleasure of showing you how to use Excel today. Don't get too excited. It's not that fun. That's funny because I dreamt of the same thing last night. I was like, man, I can't wait to get into chemistry class. Get to use Excel. I literally had to work through it last week just to refresh my memory. Give me a second. Give me a second. Give me this. I will openly go on and tell you, I am not going to give you another one of these. It's your responsibility for you to keep up with both of these sheets that I'm giving you. Such much fun. All right. Well, you guys are writing that down. I'm just going to explain this to you really quick, how we're going to get the density. Okay? Density is equal to mass divided by volume. So literally on every one of these, all we're going to do is take the mass, divide it by the volume, which we luck out because we decided to use 10 milliliters for every one of those. It's like, wow, we were smart when we did this with a purpose. So, if you don't believe me, you can absolutely be the person to punch this in your calculator.
Just leave the decimal.
I chose to ignore you. I cannot stand it when people say that that's mathematically incorrect. I got shocked whenever I had a math teacher here come up to me. Nope. She said there's nothing wrong with my scoop method. And I was like, what are we talking about? Ice cream here? And then they told me. And I was like, oh. I see everything wrong with your scoop method. Yeah, but we just went back and forth and just messed around.
It's funny when you let
She is absolutely one of the smartest people I've ever met in my life.
She's like another human being.
I had printed out some stuff from my chemistry class either last year or 2 years ago, and some of them were left in the teacher's lounge, and she brought them to me, and she asked me if she could have one to work it out for fun. And I was like, you want to work this out for fun? I have kids in this room screaming about having to work it out, and you want to do it Fun?
Yes, that's.
And she said yes with a smile on her face, and I said, sure, Miss Cole.
No, we'll be doing something in there, and she's like, oh, this lesson is fun, and that actually means that it's
It's
gonna
hard.
ruin your life.
Yeah.
Well, at least we have some similarities in our lives.
Yeah, but you openly expressed that we're definitely gonna have some discomfort going over the subject.
Yeah, we haven't even hit discomfort yet. All right, so there's all your density, and all I did is I took the and divided it by the volume. Now, here is the interesting thing, and this is what I want to stress out, because a lot of y'all have these questions of how is it you can figure these out? As of right now,
Well, the guy that's like, how much
Density
sugar?
divide volume?
you cannot figure it out right now. And I will openly tell you, do not copy down. You copy down what's on here. Those values I gave you for these right here, off that percent label, I started looking at that and I was like, man, I'm really bothered with how they're presenting this on their labels. This is bothering me. So I looked it up, and we need to calculate this a different way. Give me a second to get this down, and I'm going to show you how to calculate these off these bottles.
They were doing it for certain.
Still doesn't matter. Alright, for the purpose of this lab, while you're doing that, I'm just going to explain this to you. You can go back and watch this video later on. We're recording. So in this is what I want to stress to you. Let's see, what color are we going to do this in? I already used purple.
Red.
Red, push red and blue, that works. It's a stop bar.
Okay, so in this, how did we get these 1%, 5%, 10%, 15%, and 20% sugar solutions? Here's my data table. This is what happens when I'm gone for a couple of days. My desk is a mess. Alright, so this is what we did. Okay? Everything I did is I took it as if it was 1 liter. So this is how I made these solutions, because this is important that you did this, that you know how to do this. So I took 1 liter of it, of a solution that I was making up. So everything was going to be equal to that. Now, in terms of that, everything is made off of a percentage of it. I did it that way because in 1 liter, we're looking in terms of everybody being 1,000. So in this case, you're dealing with percentages. So you look at this, so let's say for the 1% solution, I needed to figure out what was 1% of 1,000. Which equals 10. So in this case, there was 10 grams of sugar in 990 milliliters of water. I did this for all of them. So for the 5% is 50 grams of sugar and 950 milliliters of water. $100 grams of sugar and 900 milliliters of water. We did 150 grams of sugar in 850 milliliters of water. 200 grams of sugar in 800 milliliters of water. That one was a pain. And every one of these corresponds. So this is the 1%. This is the 5%. There's your 10%. 15%, and 20% sugar concentrations. Okay, this is what you're looking at. How we did this. It's important that you understand how we did this to give us the percentage, because that's what we're going to have to do with these labels. So in this, whenever you're trying to find the percent sugar in the label, so percent sugar off label. You will take the mass of sugar, bless you, off bottle, divide it by volume of the bottle. Now this is the key. You do want to make sure you're doing this for one serving, because everything's in serving size. But here's the key for us. Every one of these are like this. Every one of them says one bottle as a serving size. I know it's hard to see. I can clean that up here. There you go. See, said where it says serving size, one bottle, all of them say that. Except for the can of Monster, it says one can. Okay? And whenever you do this, of course, you have to multiply by 100. So this is how we found all this information. So for example, I'm going to do the first one. Okay? So Dr. Pepper. So on Dr. Pepper, on the bottle, here, you look. Focus, I tell you. And look where it says total sugars. You see where it says 65 grams?
Yeah.
There's the mass of the sugars off the bottle. So we're going to take 65 grams. Divide that by the volume off the bottle. All of you are absolutely correct to look at me and say 20 ounces. But do we use that system?
591 milliliters.
591 milliliters. So 591 milliliters. And we're going to times that by 100. That's the quantity is going to be times by 100, okay? Don't get this mixed up and say that you're going to multiply 591 milliliters by 100. That'll get you in trouble. So in this, watch the calculator. 65 divided by 591 times 100. And I find it to be 10.9983% sugar. So in this, go up here, Dr. Pepper, 10.9983%. It is crucial that you can understand how we solve for that. Then all the other ones are here for you as well. Okay? So, on the bottle of Coke, I know it's a little harder to see, but that one is also 65 grams. And that's 591 milliliters. So, I'm not going to do it again. It'll come out being the same thing. 10.9983%. Let's go to Zero Monster. This is the one where I started looking and saying, hold up a second here. Alright, in this case, you're going to be looking at your carbs here. Pretty much all the sugars that are in this thing are your carbs. So 58 grams. And here's the big difference. This is a 16-ounce can. So you're looking at 473 milliliters. And I know on that can it says total sugars are 54 grams. Okay, that's when you're looking at the added sugars. We're going to look at everything in there. So we're taking all the carbohydrates into account because all carbohydrates will break down into simple sugars. So the percentage I get for the Monster is 12.2622%. That thing's concentrated. Then for the Mountain Dew, which is a popular for people to jump for. Looks at your total carbs on here. It's the same as your sugars. Hopefully you can see it, 77 grams. And this is back to a 20-ounce bottle. So 591 milliliters. So we're looking at 77 by 591 times 100. So we get 13.0288%. Then my personal favorite, apple juice. I bought 2 of these just so I could have something to drink. That's not the one I stuck back in the lab, by the way. Before anybody says anything. I know that one's really hard to see. See if I can get it. 41 grams are your total carbs. So 41, and this is a 12-ounce bottle. So you're looking at 355 milliliters. So we're looking at 41 divided by 355 times 100. Give us 11.5493% sugar. For the most part, not really shocking. Any questions on how we got that data? Y'all need to see it better up. There are your numbers. I know my 3 looks really bad right there. This one's Dr. Pepper. This one's Coke. This one's Monster. Here's Mountain Dew and apple juice. So no questions on how we got that information there. Wonderful. You guys are doing great. From here, were there any labels for our 1%, 5%, 10%, 15%, 20%?
No.
No, because we made them, and then you're about to find out why we made them like that. So you have nothing you can put here. Then you got these highlighted parts. That's where these solutions that I made up, comes into play. Okay? And this is where Excel comes into play. Beautiful, wonderful Excel. computer. And on my computer here, you can see a couple things. First thing, this right here is ultimately what you're after. The reason you're ultimately after this graph is because of the information that you're going to pull from this graph. I'm going to show you how to make this, but the key to it is, before we go into making these, look how everything's labeled. Zoom in a little more. There is a graph title. You must place a title on your graph. You have to call it something. You can't just put a graph there. I have to know what this graph deals with. From there, it's nice to have a little key over here. This tells me what everything is. So this right here, my blue dots, are the density of solutions. That line is the linear density of solution in grams per milliliter, and you can change those if you'd like. Then right here, no, stop that. I hate you, Excel. Listen to me. This right here is the key. That right there is what we're doing this whole thing for. Is you are literally making Excel work for you so that you can get a slope-intercept equation off of this. From that, you can work backwards to fill in these. But you have to be able to do this first. So, work through and bear with me. It's been a couple of days since I did this. So everybody say bye-bye to the graph. Alright, so in this, showing you what I've done. Because if you do not know how to punch this stuff in here, then God help us. So what I've done over here on the left column, I pretty much what it says, okay? So I have the solution mixture. And I went through and labeled every one of them. 1%, 5%, 10%, 15%, 20%. Then I went Dr. Pepper, Coke, Monster, Mountain Dew, and apple juice. Per what we had in there. From here, I put the percent sugar concentration. Now, you don't know the percent sugar for the Dr. Pepper, Coke, Monster, Mountain Dew, and apple juice. That doesn't matter. You're using Excel to figure out a way to solve that. So we have 1, 5, 10, 15, and 20% sugar concentrations. Next to that, I have the densities of the solutions as we calculated them out. So 1.0061, and I put the units up here for what it goes for, okay? So grams per milliliter. 1.0237, then I have 1.0425, then I have 1.0595, and 1.0827. Now this is what you're going to do. When you got all of these labeled, Excel's going to do the work for you. And you want to make Excel work for you. And this is where it's been years since I've done this, and it becomes a whole lot of fun. Ultimately what you're going to do, you're come to your last data point here, you're going to left click, and you're going to highlight all that section. What we're highlighting are our X and Y axis and the plots that we're going to make here. So from here, I think it's in maybe insert or draw. It's insert. So go to insert. You see here where it says charts? In every one of these are different charts that you can make, which is what we would be looking for. You need to think whenever you're making a chart, whenever you're making a diagram, what makes sense. In this case, I have some points that I'm wanting to plot. A bar graph will not make any sense to me. It's not going to help me in any case. But the scatter plot will. So click on the scatter plot. I do not want scatter plot with lines through them. That's not going to help me, but a scatter plot with just points helps me. So click on the scatter plot. And looky here, this is what pops up for us. Isn't that nice and pretty, ladies and gentlemen? I cannot talk today. That is so nice. Look how nice of a graph that is. But there's some problems with this graph. What's our problems?
It's not labeled.
Not labeled. You have a title labeled, which is great. Is this y-axis labeled? So me as reading your lab report, I have no idea what this represents. Because whenever I'm grading this as if I have no idea what you've done. So every piece of information you can include in here is crucial for me to see. Do I know what this x-axis is?
No.
No. Do I know what these blue dots are?
Nope.
No. They're just blue dots. Why do they matter to me? And this is where Excel will work for you. Go over here where it says Add Chart Element. Okay, when you're trying to add something to your chart, that's what you're looking for. Click down on that and it's going to give you some options. Okay? So in this, we're going to want to label some axis titles. That's pretty important, right? So we have the horizontal axis. Hey, that gives me where I can label the x-axis. That's beautiful. We'll click on that, but hey, we need some other stuff here.
Y-axis.
So we're going to need, go back to this axis title, we're going to have to label this y-axis out. Gives us the ability to label the y-axis. I'm pretty sure it says vertical on there. I didn't address that, but I think it says vertical. Yeah, primary vertical. Okay, it's already on there, so that's why I was taking it away. We already have a chart title there. Okay? So, chart title's there. We can edit if we like. Alright? From here, we need to do some other stuff. What else is missing?
The line.
The line. So I'll show you how to do the line, okay? So you go to this Add Chart Element, and you go down here to where it says Trend Line. Okay? In this case, we're looking for something that's linear. We're just looking for a slope-intercept form. I cannot speak today. Man, y'all are going to watch this video and be like, my gosh, he's horrible. In this slope-intercept form, okay, what type of line would that be?
Linear.
A linear line. So we're going to click on linear, and that gives me the linear line. Now there is something that I do not like about this linear line.
There's dots. It's not a solid.
I'm fine with the dots. That doesn't bother me. If you want to change it to where it's solid, that's fine. But there is one thing that drives me nuts here.
It doesn't go all the way through.
Nope, no problem.
What is the problem, Mr. Hall?
They let me do
It's not accurate.
What color is my dots?
Blue.
Same color.
What color is my line?
Blue.
That kind of bothers me. In this case, if you left it blue, I wouldn't take off for it. But for me, it drives me insane, and I just can't do that. I think it's right here, Fill in Line. So you click on the line. You go to where it says Fill in Line. Should give us the option.
Yeah. Oh.
So here over our color, we're going to choose the outline color. And I'm going to go red. I like red. Boom. Now I got a red line, so I can still see my blue dots, and I still can clearly see my line popping through here. Is there anything else?
Key.
You gotta label your axis title and your axis.
We need to label those. Something else.
As somebody else said, I don't remember if it was a key.
Here's what you need. Over here when it comes to this format trend line, I scrolled down here. So right here where it's got the bars, you're going to click on the bars and it'll start you up here and you don't see it. Scroll down to the very bottom. We are literally designing this. Okay, you're getting to set how this trend line looks. And this is what the grand scheme is that we're after. Display an equation. You need this equation. So there's the equation. I hate the equation being there. I hate the equation being over here also, but we're just going to set it there for now.
So it looks whack.
Better than being in the middle.
It's a lot better than being in the middle. Okay, I know some professors, I had some professors in college that actually wanted this to be right here under this line. In that case, when you get to college, remember one thing.
Based on perspective.
Is Mr. Hall grading your stuff then? No. So do you care what Mr. Hall's opinion is at that time? No. Put phooey on what Mr. Hall says. You listen to the professor. If the professor tells you that he wants this up here at the top left, Where are you going to put that thing?
In the top or
In the top left, because he will take off for it not being there. Trust me. You guys are not the friendliest people. Alright, and then we need to get that key chart over here. So we should find it under Add Chart Elements. I'm trying to do it the hard way. It should be Legend. And we're going to do it at the right. So, doing that again. Go to Add Chart Element. Go over here where it says Legend. And you're going to look. You got all sorts of options here. I don't like the left. I do not like that bottom. I despise the top. I like it to be on my right. So we'll sit over at the right. And this is how I like to set this up for me. I like to take my equation and put right under there. Because it makes everything look so crisp and clean. And you can raise this up if you want. I probably would. I'd probably set that about right there.
So it's even.
And I take this, and I'll still want it with it, and I would set it there. Alright, now it's time to label your axis. And in this, you can actually size this up so you make it longer, bigger. Right now, all you got is what fits on this screen though. Oh, no, don't do that to me. What are you doing? Very finicky. Okay, so here you can see everything. And the cool thing is you can actually size this out more if you like, so we can slide it out. You can size your graph however you'd like, so I'd probably slide that out over there. I'd bring this back up here, because I want that graph. I want that graph to be able to be seen. So here's the thing. I think, Maddie, you said this, that we still need to label these, or it might have been Caitlin. Okay. So we need to change these names. So let's look at this x-axis. What are we going to call that x-axis?
sugar.
Percent sugar's fine. Because these are the percentages, okay? So 20%, 15%, 10%, 5%, and 1%. Those are the percentages of the sugar concentrations. It's totally fine. Now over here on this y-axis, what are we going to call it?
Density.
Density. I would say this word. Density of solution. And in that, we need units. So grams per milliliter.
So it would be the same as the title?
You can change the title.
Density of sugar solution.
Let me change my title. So density of sugar solution. Solutions. Sorry. I'm perfectly fine with that. You got everything labeled on here, and this is why this matters. You can take this, copy this, go into Microsoft Word. We'll just use this for an example. And you can paste it. And it's in there. You made this to go in a lab report. So you need to insert that into a lab report. Okay? So now you've dealt with, you've dealt all with this. What?
Looks like something disappeared.
On what?
On the chart thing. Scatter plot.
The red line did. It's fine. You'll fix it. Okay. So on this, you've dealt with all this. I want to talk to y'all real quick about the sheets that I handed you out. The red line there disappeared. Fix it later on. Alright, this right here, this is the cover page example that I gave you. Your lab report needs to have a coverage page. This is a page that stands alone by itself, and this is what you need to have on it. You need to have a lab report name. Because you're in a class, a lot of people like you to put a class name. I'm requiring you to put that class name with the period, so I don't get these papers mixed up. And then your name. Then you have to write an abstract under it. Understand, abstracts are just short summaries. They're going to summarize what I'm going to read about. They should tell me about what this is about, and it also should tell me about your results. So a lot of people suggest just doing it really quick, do the report, and then come back and write their abstract. Okay, I agree with that. This should be short, but it should not be as short as density solutions of sugar and soft drinks. We measured density, mass, and sugar inside soft drinks, and call it done. If you do that, you're not going to like what you get. Okay? From there, I want to go through all of these. You can read all this stuff later on. All let's talk about is a heads up. You should not include identifying pronouns and stuff like this. You should not say he, she, we, me. You're looking at dry, people. Okay, you're just putting the facts out there. You're just saying the facts. You're just telling people what you did, but you're telling them without saying, I did it. You're just giving directions. Every one of these these bold sections is a section that should be in your lab report. Okay? So the introduction. Introduction is simply an introduction to the lab. Why are you doing this? What's the point of this? I'm not going to give you an answer to that. I want you to think outside the box. What was the point of doing the lab that we did? It shouldn't be too hard to think about a reason behind it. Here is materials. The material section is quite possibly the easiest section in the world. You list out the materials. You don't even have to put them in a sentence. You just list them out. But make it look neat and organized. This thing should be neat and organized. If you want an example, look back at the handouts I gave you.
What's the font? What's the font we use?
Times New Roman or whatever this is that I'm using.
Calibri.
Yeah.
What size? 12?
12. You use 12. And it needs to be double spaced. It must be double spaced. Do not turn something into me single space. You turn it into me single space, it gives me no room to write on it whatsoever, and I'm just going to put a big X on it and say that counts as one of your turn-ins. Sucks. Then you got the procedure. Procedure goes through what you actually did in the lab. You can read through all that. Then you have your data analysis. Guess where that table, that graph we just created should go? Data analysis. Then you have the results. Talk about the results of the lab. And then the conclusion. For anything I can stress to you in the conclusion, it is not a summary of everything you just told me. Tomorrow you will report to lab 1110. Have a wonderful, fantastic day.
20 meter hall.